This is our senior design presentation for our grain bin rescue system. By Ben Wilmoth, Kevin Mills, Ryan Zender, and Spencer Gibbon. We would like to thank our advisors, Dr. Sanderson and Dr. Montross, and the Southeast Center for Agricultural Health and Injury Prevention for providing the funding.
Farming is among the top 10 most dangerous jobs in America. There are safety hazards around every corner. This project focuses on the safety issues associated with grain engulfment and entrapment in grain bins. A typical grain bin and auger are shown in figures 2 and 3 for those of you that haven't ever seen them before. Grain engulfment and entrapment are bigger issues for family farms rather than large corporations. This is because large corporations are required to follow OSHA regulations, while family farms are only recommended to follow those same regulations. However, there is no way of enforcing those regulations on family farms. The main rule to be followed for large farms is that there has to be 2 or more people involved while entering a grain bin. Since this can't really be enforced on family farms, people enter the bins by themselves all the time. The issue is that most of the products available for safe entry into grain bins require 2 or more people to operate them, and the products made for single-person operation are far too expensive for small farms to afford. Grain engulfment is a serious issue currently facing farms in the United States. In 2019, 38 entrapments were reported, with 56% of cases resulting in death, a number that has been on the rise in recent years. The potential for grain engulfment to occur begins when an individual enters a partially emptied grain bin without adequate safety precautions being taken. Many of the dangers associated with grain bins do not immediately present themselves, but instead lie below the surface. Grain in bins can mold due to high moisture grain being harvested and not adequately dried before storage. This can result in grain clumping together, which is also known as bridging. Bridging becomes dangerous after a bin has been partially emptied, which creates a void underneath the moldy layer of grain. This bridge is impossible to see with the naked eye and may look and initially feel solid. However, if stepped on, this bridge can collapse, resulting in an individual falling into the void and being fully engulfed in grain within a matter of seconds. This can be seen in figure 1 at the bottom of the screen. Another common cause of grain engulfment involves a lack of communication and the use of the unloading auger. An individual may enter a grain bin without notifying others in the area. Other workers on the farm may engage the unloading auger and begin transferring grain to another bin or loading a truck. The grain in a bin is emptied from below, which causes the top surface of grain to act like quicksand. For anyone inside, they have only a few seconds to react before being trapped. After 5 seconds, an adult would no longer be able to free themselves from the flowing grain, and in as little as 11 seconds, an individual can become completely consumed. Death from grain engulfment occurs from intense pressure caused by grain on your chest. This prevents your lungs from letting air in or out, which results in no oxygen traveling to the brain and is known as suffocation.
The design of the safety system had 2 goals in mind beyond preventing grain engulfment. Those were simplicity and lightweight. The design only consists of 5 components: the bin mount, the spool, the manual lock, the automatic lock, and the tensioner. The mount consists of 4 adjustable legs held in position by 2 pins each. This is so the device can mount to multiple sizes of grain bin. The legs must be adjusted to the approximate size of the fill hole on top of the bin, then the bolts at the end of the feet take up remaining play. At initial glance, the rendering makes the device look very large. The device is fully compacted at 24 inches across and extends to a maximum of 48 inches. The safety mechanism bolts to the mount and consists of the other 4 components. The spool is a center rod with bearings on both ends that every other component indexes on. The spool's main purpose is to have the safety rope coiled on it and allow the rope to extend and retract based on the user's need. The automatic lock stops the spool from releasing any rope when very high angular acceleration is sensed. There are several spring-loaded pawls on the automatic lock that are forced into slots in the mount that stop the mechanism from turning. This is necessary for large bridging engulfments because they happen very quickly. The manual lock is engaged by the user by pressing a button on their safety harness. This sends a wireless signal to the manual lock on the mechanism to trigger engagement. The trigger holds back a spring-loaded steel pin in the mount. The pin is forced into slots on the spool that stop the spool from turning and releasing more rope. This is needed due to the slow nature of an engulfment caused by an auger. The last component in the design is a spring-loaded tensioner. This keeps a small amount of tension in the safety rope to assure that there is no slack. If the line attached to the user is slack, neither lock would be effective because the user would have to fall to take up that slack. This would render the entire mechanism useless because the locks would not stop an engulfment from happening. The tensioner works similarly to a pull start on a small engine or a seatbelt mechanism in a car. The tension isn't so high that the user would be uncomfortable, just enough to take up slack.
This is our bill of materials. It includes all of the steel and aluminum that are necessary to build the mechanism and bin mount, as well as the harness worn by the individual in the grain bin. Our total price came out to roughly $980 for our prototype. If we were to manufacture this product, our total materials price for each rescue system would be significantly decreased due to the amount of products we either have to or cannot purchase in bulk. Many of the metal parts could be purchased in full size for a much cheaper price per pound, but they are not ideal if we are only making one rescue system.
When looking towards turning our conceptual design into a physical product, there are several considerations we must take into account. The first is how grain bins have little to no structural support, especially when empty. From looking at several manufacturer sites and doing some simple calculations, it would appear the minimum load the roof can stand, no matter the material or size of the bin, is nearly 5,000 pounds. By adding a rescue system, we do not want to compromise the structural support of the roof and bin itself. Next, we have to remember that this is a time-related issue. An auger typically moves 41 cubic feet of grain per minute, and the average farmer being 6 feet tall takes up 7.5 cubic feet of space. After 5 seconds of the auger being turned on, the farmer is stuck from the waist down, and after 11 seconds, they're completely engulfed. This device must be able to react quickly because the removal, once a person is waist deep, can be tricky. They are unable to free themselves, and lifting them out can take nearly 500 pounds of force due to the weight of themselves and the weight of the grain pushing up against them. And this can result in dislocation of muscle and sometimes paralysis. Another consideration is how this device needs to be cost-friendly. According to our economic analysis, an average small farm family will not spend more than $1,000 on a safety device. So, our production cost needs to be as minimal as possible while still maintaining quality. Lastly, we have to make sure installation can be complete simply as the system will be hard to access and will be hard to work on in the future. Some of the next steps we have to take involve selecting spring sizes for our mechanism, completing the assembly of the device itself, and doing a failure mode element analysis report on, or a FEMA. This will gain a better picture of where this device could fail with user error or even outside conditions influencing it.